So, hi everyone. Been a while since we've done a technology video on the channel, and mainly because I haven't had anything to really do on technology other than fix Exchange 2013 and a bunch of other stuff in software, which wasn't very interesting. However, this one might be. So what we're going to do here is I'm going to build a PFSense router and firewall, and there's a couple of reasons for this, but to start with, let's go through the components that I need. So I've got actually 3 racks on my premises. So there's 2 small racks which hold network switches, existing broadband router and patch panels, because the whole property's wired up with Cat 5 and wireless. The 3rd rack holds all my servers. So what we need is a Rackmount chassis to start with, and I'll run through the components on this. So we're going to build essentially a 1U Rackmount dedicated router. Now I could of course go and buy a dedicated firewall router box, but to be honest, they are eye-wateringly expensive because they're pretty much designed for the enterprise market, and you won't get much change out of £10,000, or about 5,000 actually, and then a bunch of maintenance and software on top. So you're looking at a substantial investment, and there's absolutely no need for that. Also, whether you're aware or not, but the capabilities, if you like, in terms of technology on a normal broadband router is pretty minuscule. You've probably got more capability in your smartphone than you do in one of those boxes. So what we're going to do is build a cheap rack mount unit which uses essentially open source software. PFSense, I think, is, and somebody correct me if I'm wrong, is based on the OpenBSD Linux distribution, which is probably one of the most secure Linux distributions out there. PFSense itself is just a Linux PC based piece of software to do routing and firewall. There's also a whole raft of add-ons on there, so you can do things like firewall, you can do packet sniffing, so you can inspect packets and see what traffic's going in and out of your network. You can do VLAN segregation, all kinds of stuff. Now, because I run 2 1 gig switches, I don't really need the VLAN functionality. All I need is the firewall and the router itself. Now, the reason for that is, whilst the existing broadband router and firewall is sufficient and does a fairly good job, the issue has become recently where, okay, so your firewall's essentially protecting your network from traffic coming in from outside on the internet and blocking it, so it's essentially a filter. Increasingly there is more and more software, and now we're Windows 10 operating systems, which is talking out of your network. So really it's got to the stage now where I want to know what's going out of my network, and then blacklist essentially in the firewall any addresses which are harvesting data I don't want it to harvest, quite frankly. So essentially the internal, so if you like, you've got an externally facing firewall, and what we're doing here is we're setting the one up that's going to face internally as well as externally in this box. So you get a double layer of protection from attacks from the outside, and then you get a layer of protection coming out of the firewall. Now you can also filter stuff on the broadband router as well, but to be quite honest, I don't trust a lot of broadband routers. Certainly wouldn't trust ISP provided kit, and I don't use it. I use either Linksys or Netgear or something along those lines. However, there have been vulnerabilities found in those as well. So essentially, because of the data and valuable software and data that I keep on my servers, I need full control of the network, and this is essentially going to achieve that. So what have we got here? We've got, in the first instance, a 1U Rackmount Chassis, and this is completely bare bones and comes from RS Components. It's about £40, 40 something odd, and it's already got your ears for mounting into the rack, which is good news. And let me just pop the top off this so I can show you. Top off this, quite a decent little rack mount chassis, to be quite honest. The sides, the top and the base are all folded. It's like some kind of galvanised steel with good connectivity on the tabs between all the surfaces, so you've got a decent grounding and shielding there. As I said before, the chassis is completely empty. The front and the rear panels are made of aluminium so that you can cut your own ports and holes out of that. And then we've got the internal. Now I've already put some little standoffs here, and then we're going to build the machine in here. Now obviously not everybody uses racks. Most people don't use racks, so if you don't have a rack and you don't want a box like this, there are loads of other enclosures that you can get, and probably the best thing to do is to get hold of a mini ITX case, cheapest one you can find, because what we're essentially building in here is a PC, a small mini ITX PC, and the heart of that is I've used this Gigabyte J1900 ND3V, which is a mini ITX board. You can see it there. I've already put RAM on there, and now I've put 8 gig just because I wanted to fully populate the slots, but there's no need for that. You hardly need any memory at all for PFSense, and to be quite honest, if you've got an old spare PC, you could turn it into one of these. It's just that this is going to be a neater package, basically. So this has got a built-in Celeron processor on it, and I'm not too fussed. As I said before, most smartphones are more powerful than routers and firewalls. This CPU is going to be fine for that. But the main thing that it did have, and why I selected it, is because it has 2 network ports built onto it, 2 gigabit Ethernet ports there. We don't need all this other stuff, to be honest. I mean, I'll use the built-in either DVI or VGA just to configure the thing and get it up and running, but once it's in the rack I'll never need it. But obviously you need 1 port for inbound traffic and 1 port for outbound traffic. Now you could add another network card on the back, and then, you know, network cards that do 1 gig 4 ports are fairly plentiful and not too expensive these days. Don't think there's any need to go 10 gig just yet, but obviously there's some expandability options on here in the future. Or I could put a wireless card in here as well if it doesn't already have a port for it somewhere on here for a wireless adapter, and that would essentially give us, you know, we could use it as a Wi-Fi access point as well, which I may do because I think I prefer to have my wireless network, all of my wireless network, inside this second firewall, or I can leave my existing broadband router essentially with its wireless on there and use that as a guest network. So if you can imagine this is a kind of Mott and Bailey castle, I can keep the guests, as it were, out behind the curtain wall, but all the valuable stuff is inside the keep. And essentially this box and the broadband router firewall act as portcullises essentially. So that will fit on there, and I'm thinking it will go around here. Obviously you'll have to cut the I/O ports out from here, but having a CNC machine, that's something we'll come on to as well. I can cut the output there with a bit of modelling, and it's just fairly easy 2D work. These front and back panels actually come off of the chassis. They're quite easy to remove, they just snap into place. We've got to cut a hole on the outside of the chassis. Now this is a 1U power supply unit, so we're going to have to mount that in here, and with its power port at the back, just there with some cabling. Now we're going to need a little bit of storage. We could either use a, we're going to need the operating system and PFSense plus its add-ons on storage. Now I could use a USB stick for that, but I've got a spare 240 gig Corsair SSD here, so we're going to put that in, and that'll be somewhere around this midsection here. And really all we need to worry about then is cooling for this unit. Now there's obviously going to be a bit of heat coming off of the heatsink. So the CPU, I think it's an Intel, yes it is an Intel Celeron, as I said. The CPU is going to generate a little bit of heat. Shouldn't be huge because I'm not exactly going to be stressing this CPU out with the work it's doing. So there's going to be a bit of heat coming off there, the general motherboard components, a little bit coming off of the SSD, and then some coming off of this PSU. Now this PSU is a 250 watt PSU made by a company called FSP. It's pretty inexpensive. In fact, this whole setup will come in, and without too much shopping around. Now we're talking 100 for the motherboard, including the CPU. We're talking including the CPU and the RAM. So it's 140 including the chassis. You've got an SSD, 240 gig SSDs are about 40 quid now, so you're talking 180. 40 quid for a, I think it was 40 or 50 pounds for the power supply unit. So we're up to just under 200, and then we're going to use a Noctua fan, which is just going to push us a tad over the £200 mark. Now obviously if you run your own company, then you'll be potentially claiming the VAT back, which makes it even cheaper essentially. So just put that there. So now I always use Noctua fans and have done for years now, because A, they're quiet and they seem to just go on forever. I've had Noctua fans in some of my PCs probably going on 7 or 8 years now, and they're still running, and they're still running quietly. So what are we going to do with the heat in here? So we're going to have two main sources of heat really. We're going to have the CPU and the PSU, and we've got no ventilation at all in this chassis at the moment. Now I don't have the ability on the CPU to put a fan on top of that, or I probably could. I could probably take the heatsink off and mount something to it. However, it's probably far easier just to suck all of the heat that's coming out of this unit straight out the top. There's going to be room above it in the rack, which will then vent out the rack. The power supply unit has a little 40mm fan in the back of it, so that can exhaust out the back of the case, and I'll do a cutout for that. But any excess heat that this creates, and they do tend to create, these small form factor PSUs do tend to create a lot of heat, we can just vent out the top of the case. Now what that's going to mean is I'm going to have to mount the fan underneath the top plate here, which means I'm going to need a magnet can stick to that. We're going to need some vent holes and the 4 holes for the screws to mount there, and that will sort out our hardware arrangement. So that's what we're doing here, and as I say, it's really just a very small form factor PC, and that's pretty much what most switches and routers are. It's just they're using dedicated hardware. We're essentially almost creating our own dedicated hardware here. It's just we're using off-the-shelf PC components and doing it with new components, but pretty cheaply. I mean, you know, £200 for a dedicated firewall router is quite frankly peanuts, especially one which has got the programmability, if you like, and flexibility to do a whole host of other things if you need to do it. So things like you know, packet sniffing. I could use the hard drive on here with a partition to essentially use as a small VPN enabled you know, internet accessible storage device, so I could put files maybe that I want to share with friends on there, give them essentially access through the firewall onto this architecture so that they can access, you know, shared files. I do a lot of, you know, music creation, as you may have seen on the other videos, so sharing raw music with people that I'm collaborating with is a useful thing. So there we have it. So what we'll do now is we'll step over to the PC and Fusion 360 and get on and CAD up the front panel, which also is going to need an on-off switch on it. I should have one of those knocking around somewhere, because all it's got to do is make a momentary connection on one of these pins here. Essentially you short it momentarily, it starts the PC up. That's so that we can do essentially reboots in the rack when it's in the rack, because the idea is mount it in the rack, forget about it apart from management across the network, and never open it up again. At least that's the theory. Okay, so over to the PC and we'll get on with the CAD work. So here we are in Fusion 360 as usual, and we always start with a sketch, and you can see here that we've got various measurements I've taken from the I/O plate that came with the motherboard, and essentially I've positioned that on a rectangle which is the same size as the front panel for the rack mount case. So that's the sketch. If we just click on stop sketch there, what we did then with the sketch is we extruded that sketch out. I think it was 1 or 2 mil to get our body. So you've got the 3D body there, which shows essentially the surface of the panel. Not interested in modelling the bent over sides. And from there we can go into CAM, and I'll just have to quickly regenerate the toolpath. So that's that done. The setup, obviously I've made the stock the same size as and thickness as the rectangle, and then we can click on the first toolpath, which is the adaptive clearing, which is the trachoidal toolpath, my favourite strategy, which is what makes Fusion 360 probably one of the standout products on the market, especially as you can get it for free within certain parameters. And that's going to come in and essentially mill out all the slots here. Now that's a roughing pass, it should be okay. I've taken it right up to the limits, if you like, of each of the pockets, and then come in with a chamfer which just runs around the edge of each of the pockets just to put a little bevel on there, which makes it nicer to deal with. You're not cutting your hands on sharp edges, and it looks prettier as well. So we'll just go into the simulation for that, and bear with me while I just switch the toolpath off and the stock on, rewind it as well, and then we can hit go on here and we can watch the toolpath cutting the various pockets out. Now I also made the depth of the cut slightly deeper than the thickness of the aluminium I'm cutting, just to make sure it goes through, and I'll have a sacrificial board on the machine that I can cut into without worrying about destroying the metal bed that's on the bottom of the machine. So there we go. This is going to be fairly quick jobs, and there you can see the chamfer mill running around the edge, putting the chamfers onto the various pockets. Also probably worth pointing out that here also you've got the cutout, 60mm cutout for the on-off switch, which I'm going to put in. So that's pretty easy. It doesn't in fact get much easier than that. It's pretty standard kind of 2D milling, and then obviously I needed to do one for the back plate here, so you can see that that's where the power cord will plug into. This is where the fan exhaust will be. These are the mounting holes, although these mounting holes probably not going to exist because the top of the back of the case, if that makes sense, is actually split around about this point, so we may not actually get this in here. But as long as we get these two pockets in, and I can always drill this hole to mount the and use a bit of hot glue or something to mount the power supply in place. And then the top, now this used a set of circular patterns. Actually, if I just run back to the sketch on this one, and we can have a quick look at that. If I click on edit sketch, look, there you go. So essentially each of these holes, I did the holes and then did a circular pattern. It's quite easy to calculate the number of holes that you need in each of the patterns, so it does a circular pattern all the way around. And then the mounting holes I think are 120mm between each point. Let's just check that. We can go to inspect, measure, select that point there, select that point there, and if I bring the window on so you can see it, then you can see actually 125mm apart there. And we can do the same in the vertical, but as we know that's square, that's going to be the same. And again, that's just a pattern. These are all 5mm holes. So really that's the CAD, and it was very simple. We pretty much took me probably about an hour, I guess, to do all of those, you know, the front and the back and the top. And really it's then over to the CNC machine, but we'll do that in the next videos. This will be a two-part series, CNC project. So as ever, thanks for watching this video, and see you on the next video when we'll head over to the CNC machine and start cutting this out.